Hey guys, Mr. Middleton here. Today we're going to talk about reasoning with algebra. At the end of this video, you should be able to apply the properties of equality and congruence to prove problems involving algebra, and you should be able to justify each step in a proof. Okay? This is going to be our introduction to proofs. A proof is a mathematical argument that lays out step by step how to get from a starting point, oftentimes the given statement, to an ending point. Oftentimes I'll just say the prove. Okay. Proofs are typically shown, at least in this class, as two-column proofs. Hope I'm spelling column right. Okay, but can also be flow proofs or even paragraph proofs. Each step in a proof must be justified. Must be a reason why we did it. The justification of each step uses previously learned definitions, postulates, theorems, properties, and more. This is why you must know these things as they are taught. So, some properties of equality and congruence that you should probably already be familiar with for the most part. The addition property, and that just says if A equals B, then A plus C equals B plus C. I'm adding the same thing to both sides. They must still be equal. Subtraction property, if A equals B, then A minus C equals B minus C. Multiplication property, if A equals B, then A times C equals B times C. The division property, if A equals B, then A divided by C equals B divided by C. Understanding that C cannot be equal to 0. Reflexive property just says that A equals A. Something has to equal itself. Seems silly, but you use that a lot. Symmetric property is if A equals B, then B equals A, or B is congruent to A. Sorry, I should use congruent here as well. We're talking about reflexive property, symmetric property, and transitive property. Okay, the transitive property says if A is congruent to B and B is congruent to C, then we also know that A is congruent to C. Okay, start these three because those are kind of the new things that you didn't necessarily talk about last year a whole lot, and they are used pretty good chunk, so you need to make sure you're familiar with those and that you can differentiate between the three of them. Substitution property just says that if A equals B, then B can replace A in any expression, and vice versa. A can replace B in any expression. And then the distributive property, just distributing this through, if A plus B, A times B plus C will be A times B plus A times C. Okay, so distribution as you've grown familiar with it. Alright, so these are just putting some definitions to things that you should be mostly familiar with. Make sure you are familiar with these, because not having to spend a whole lot of energy recalling what these are will make it a little bit easier for you and kind of seem more natural of what we're trying to actually do and just justifying each step. Okay. All right. Now this bottom section, they want us to name the property being shown or use the property given in parentheses to complete the statement. So for this first problem, we have x plus 4 equals 3x. If x plus 4 equals 3x, then 4 equals 2x. What's happening? Most of you guys have noticed that we lost the x on one side, now we have 2x on the other side. Well, what do? We did the subtraction property. Okay, what we said was, hey, these two are equal, so if I take x from both sides, they must still be equal. Okay. Alright, here we said they want us to use the substitution property. It says if m equals 2n minus 5 and m plus n equals 16, we're going to use substitution, and now instead of using m here, I want to use 2n minus 5. So I have 2n minus 5 plus n equals 16. Notice I just substituted 2n minus 5 for m. That's substitution. Okay. Here they're telling us to use the transitive property. It says if angle P is congruent to angle Q, and angle Q is congruent to angle R, and angle R is congruent to angle S, then, well, we can see that angle P, through all these congruencies, should also be congruent to angle S. And we want to be careful that we don't use a statement that's already been said. That wouldn't necessarily be transitive property rather than just recalling what's been given. Alright. Number 4, if you would, do number 4. Tell me what that is. Bring that in complete so that I know that you're paying attention and giving this some thought. On the back side, here we go. We're going into solving a problem. Not really solving it, it's solved for us, but justifying each step in the process of solving a problem. So we're given this algebraic expression as 5x minus 12 equals 32 plus x. We have 4x minus 12 equals 32. So what happened in this problem? Usually if you're given a problem like this, it might be good to walk through what you would do. Looks like the first step in this was subtracting x from both sides. So that is the subtraction property. Alright, important that in your abbreviation that it's clear what you're talking about. Usually you want to abbreviate subtraction with just sub, but with substitution available as well. Make sure that it is easy to tell the difference between what you're talking about. So I will abbreviate with subtract property, okay? Next, what's happening? How do we get from 4x minus 12 equals 32 to 4x equals 44? Well, I see that this 12 is missing. It makes sense that they added it to both sides. So it's the addition property of equality, but we can just write addition property here. Next, how we get from 4x to 44? Well, I see that 4 is gone. It was multiplying. We divide it by both. So division property. Okay. Typically, I like to think of this as somebody asking, well, why? Why? So if 5x minus 12 equals 32 plus x, then 4x minus 12 equals 32. Why? Well, because we subtracted. Then that means 4x equals 44. Why? Well, because we just added 12. Okay. Then that means that x equals 11. Why? Well, we divide it by 11. So notice that this is just the justification. We're giving the reason each time. Okay, notice again, not checking to see if you can solve the equation. The equation was solved. I want to know that you can justify each step. Alright, so here we go. Again, they want us to justify each step, and they want us to fill in the blank to the reasonings, the statements as well. So it says, they gave us this angle. It says, given that measure of angle ABD equals 107 degrees, and they want us to prove that measure of ABC is 66 degrees. So what this is saying, the given is like the hypothesis. And what we're trying to find is the conclusion. In other words, if measure of angle ABD equals 107 degrees, then measure of angle ABC equals 66 degrees. Okay, so, and then we're going to walk through why that's the case. So we need to prove that by going step by step. Measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. Okay, why do we know that this is the case? Remember that this was our angle addition postulate. Okay, so that's something that we didn't necessarily just talk about, but I do want you to remember these things because they'll continually pop up. Remember, geometry is adding things to our toolbox to use when we need it. Okay, so that's the angle addition postulate. And now they kind of gave us a hint here and said use substitution. We're going to substitute. ABD, what is ABC? That's 4x plus 2. And say 4x plus 2 plus CBD, which is 3x minus 7, equals ABD, which remember they told us was 107. All right, notice that the left side now is just condensed, okay? That is not addition, okay? Remember that addition is what happens when we add the same thing to both sides of the equation. In this case, it is us simplifying. So we're not adding to both sides of the equation, we're just simplifying. So that's what we did. Okay, some people like to call it combining like terms. I'm okay with either of those. I typically just go with simplifying, but however it works for you. All right, so what would the next step be? How will we keep solving this? I mean, my thought would be probably going to add 5 to both sides. So I get 7x equals 112. Again, I'm saying why I can do that. It's the addition property of equality. Okay, my next step is probably going to be to divide by 7 on both sides. Okay, and that will give me x equals 16. That's the division property of equality. Again, of equality because I'm doing it to both sides of the equation. Alright, and so now I found that x equals 16. So notice here that I said the measure of angle ABC is 4 times 16 plus 2. I'm doing substitution. Okay, and because now that I know that x is 16, I can plug 16 in any time that I see x. And so now the measure of angle ABC is 66 degrees. That is just simplification. You just say simplify. Because that's all we did. 4 times 16 is 64. 64 plus 2 is 66. All we do is simplify. Notice how the last step is what we're trying to prove. This will always be the case. Okay, the old saying goes, you find it, you always find, what do I say? It's always in the last place you look. Something like that. When you lose something, you say it's always in the last place you look. And that's what we're doing here. They asked us to prove that this thing is 66. Once we prove it, we're done. We're not just sitting around here and talking extra stuff. Okay, we proved it, we're done. It's always the last step. But notice, and take into account, please, that this last step will never be prove. We'll never say prove as the last step. It's not a reason. We're not saying it because they told us that we had to say it. Okay, we're saying all the reasons why it has to be that way. All right. So here's a situation we have. Suppose that A, B, and C are collinear with B between A and C. So I'm just going to draw this picture here. A, B, and C are collinear. They said B is between, not in the middle, but just somewhere in between. It tells us that AB is 2x plus 4. They tell us that BC is 15 minus x. And they told us that AC is 21. Okay, they want us to show that x equals 2. Okay, I would like for you to bring this in done on your notes. Okay, statements and solution. Okay, I'll give you a hint here and tell you that they told you to use segment addition postulate. So how would the segment addition postulate look in this case? Alright. Okay, so bring that in. Hopefully you can see how justifying each step goes, and this will lead you into our proofs, which not too far down the line. Alright, see you guys.